Well, hello, my friends. Today is the first of 2 days in which we're going to talk about that burning question. Well, what if I do long division and I have something left over? Ms. Rosner said I can't use R anymore to say I have a remainder. So today you're gonna learn how to continue dividing even after your number ends. And you're like, what? How's that gonna happen? Stay tuned, my friends. I'm going to get you all squared away with this. So let's title our notes. Math 6. We're going to be lesson 3-7. We're going to divide decimals by whole numbers. And you might say, well, what happened to lesson 3-6? Don't you worry about it. Divide decimals by whole numbers. Oh, I was doing capitals and then I stopped doing capitals. That was rude. There we go. That looks, well, let's get that W bigger too. There we go. Now it's a title. Okay. So here's what we're going to do. I'm going to start this one. I'm going to kind of go step by step with a problem. Okay. And I'm going to take up most of my first page with this. And then the second page, I'm just going to do the examples because remember, we need room when we are doing division. Okay, so let's start with this is our key problem we're trying to solve. 6.8 or 6 8/10 divided by 2. So I'm just going to use color just because I like it. Step 1, what are we going to do? Well, we're not going to divide in this fashion. We're going to divide using the division house. So we're going to rewrite the problem. Sorry if you heard that, that's my tummy rumbling. Using the division house symbol. Okay, so start 1. We're going to rewrite the problem using the division house symbol. So what does that look like? We're going to take our divisor, the supervisor of division. He's going to go out in front, and he's going to divide into our dividend, which is the 6.8. So that's your step 1. Now, even though these look like, oh my gosh, Ms. Rosner, this is agonizing. Don't worry, when you do the actual math, it goes pretty fast. Trust me. But now, what we do with our notes is now you have a place to go back if you forgot the order of the steps. That's why we take our notes, my friends. That's why we take our notes. Number 2, is the divisor, oops, I say oops a lot because I make mistakes a lot. Oops. Is the divisor a whole number? That means no decimal. You don't see a decimal in your divisor, okay? And the dividend can have anything it wants in it. Dividend has free reign. The divisor, we have to deal with. So the first question we're going to ask, is the divisor a whole number? In other words, there's no decimal. If we say yes, which, by the way, by the title, divide decimals by whole numbers, that's kind of giving you a hint that on your homework, your practice, you're going to be dividing by whole numbers every time. Just to let you know that, okay? So if yes, we're going to bring the decimal from the dividend straight up into the quotient, because remember the answer to a division problem is a quotient. Okay, so what does that look like for our friend? So we've got 2, and it's being divided into 8 or 6.8. I notice that I don't have a decimal in my divisor, so I'm going to bring my decimal point straight up and into my quotient. So it's where it needs to be. Now I can pretend I'm just dividing 2 into 68 at this point, really is what it is. But I got to make sure I keep things lined up, okay? So I'm going to write you a little note off to the side. you can't divide by a decimal. More to come. Next Thursday, oops, forgot I need to have an H there. Next Thursday/Friday. So our notes for Monday, Tuesday cover this guy, and then the notes on Thursday, Friday are going to be, well, what if there is that decimal in my divisor? Yeah. Okay, so now what do? We start dividing. Okay, we're going to start dividing. Simple as that. Okay, and it says if there's no remainder, so you end up with a 0 when you're all done and you've brought everything down, there's nothing left to divide. If there's no remainder, it's called a terminating decimal. I'm going to write it right here because this is I wanted those two words to go together. So I'm going to box those. So one of the things, if you haven't figured it out, somebody did say something on their quiz that they got the word evaluate and estimate confused. So, and probably they just looked at the E and didn't read the rest of the word. The whole point behind algebra or any kind of math, which is going to lead to algebra, you're not algebra yet. Here, I just scared everybody. You got to understand the vocabulary, okay? Math is a foreign language, so you got to learn the language. There's no choice. You just got to. So let's see what this looks like for us. Okay, so I have 2 going into 6.8. I brought up the decimal point. So 2 goes into 6 3 times. So I'm going to put that 3 in front of the decimal point because the 6 is in front of the decimal point. So I'm keeping things really lined up. Difference is 6. Bring down the 8. And 2 goes into 8 4 times, which is 8. And then I have a difference of 0. So this is an example of a terminating decimal. Okay. Now, let's deal with a what if. We do have a what if for today. What if there is a remainder? I'm going to have to dippy-do him. What if there is a remainder? So I can't just leave the problem, and I can't use R, even though that stands for Rosner. That's still not okay. So what do I do? Remember our old friend from our very set of notes, I think, on adding and subtracting? We're going to annex. Remember, we're going to add on. Annex. I can't even speak today. 1 0 at a time. And continue dividing. Okay? Until the problem terminates, or we have another possibility, is that as I keep doing this, I keep getting the same number over and over and over and over and over and over again. That's called repeating. So it either terminates or repeats. Okay? So what I mean by 1 at a time is I'll add a 0 at the end of my dividend, bring it down, do the division. If I still have a remainder, I'll go back up to my dividend, add another 0, bring it down, and continue the division. So let's go ahead and do a couple problems on the next page. So I'm going to go ahead and retitle this. Math 6. I don't care if you guys have room, do all your practice on the other page. 3.7, dividing decimals by whole numbers. And I'll remember to capitalize this time. Okay, so let's see. The directions are going to tell us to divide. Tap, tap, tap. You hear my pen? And let's do this one. So we have 3.49 divided by 4. So I'm going to rewrite that. Dividend. It's almost like I'm writing it backwards. Okay? I'm almost like reading the problem backwards. So instead of the division symbol with the dash and then the dot and dot above, dot below, we're turning it into the division house. So that's the divided by and 4. So it's like we're almost reading that problem backwards. Okay? So first thing I look for is, do I have a decimal in my divisor? I do not, so that means I can bring my decimal point straight up into my answer. Now I'm going to start dividing. Okay. And then we're going to see where we get to begin the division. Can 4 go into 3? No. So I'm going to put a 0 up there. Can 4 go into 34? And the answer is yes, it can. So what's my guess? Let's see, 4 times what is close to 34 without going over? Ooh, 8. So 4 times 8 is 32. Okay. So I subtract, and I get a difference of 2. 2 is definitely smaller than 4, so that says go ahead, bring down your next dig. So I'm going to bring down 9. How many times does 4 go into 29? Let's see, 4 times 6 is 24, 4 times 7 is 28. Ooh, that's closer. So I'm going to put in 7, and I'm going to get 28, and I get a difference of 1. And this is what I'm talking about, my friends. I have a remainder, but I don't have any more digits. So I annex a 0, 1 at a time, and I do my division. How many times does 4 go into 10? Well, it goes in twice, which is 8. And when I subtract, I get a difference of 2. I still have digits, so again, I'm going to annex a 0 and bring it straight down. And how many times does 4 go into 5? And then you're going to say, oh, hallelujah, the skies have opened and it is sunshine all over. And we get 5, which is 20. And when we subtract, we get finally no remainder. So the answer to this problem is 8,725 10,000ths. Yikes. See, this is the problem with division, folks. Sometimes we have to do it a lot. Okay? Let's deal with a problem where I have a 2-digit divisor. So again, we start with the original problem. So I have 55 and 800ths, and we're going to divide it by 17. So I'm going to rewrite it. So my 55 is my dividend, so it's going to go under the division house, and the divisor goes out in front to boss around the dividend. So I look, and guess what? Nope. No decimal point in my divisor, so I bring my decimal point straight up. And now I start going, okay, 17s. I don't know my 17s, so I'm going to have to start guessing at how many times 17 can go into 55. So I'm going to try 2 because I know 1 is really small, so I get 14, I get 34. Let me try another one. 17 times 3, that's going to give me 21. Oh, 51. Ooh, that's really close. I think that's going to work. So above the second 5, the 5 of 50, the last 5 of 55, I'm going to put my guess. So I'm going to put the 3 up there, and that's going to be 51. And then I subtract, and I get a difference of 4. So then I go ahead and I bring down the next digit, and I bring down a 0. Now, how many times does 17 go into 40? Now, let's see. I had 7 times 3 was 51. That's too big. 17 times 2 is 34. That's small, but at least it's underneath, so that's going to be my choice. So I write 2 because it's 2 times, and I get 34. And when I subtract, oops, why did I write a 6? I get 6 left over. Okay, so then I go ahead and I bring down the next digit, since 6 is smaller than 17. And I go, okay, well, I know it's greater than 3 times because that's 51. So let's try 17 times 4. So I get 28. Oh, look at that. Miracle, we got it. Oops, I just threw my pen. And so we're going to get, oops, wrong color. We'll do this guy. That's going to go in 4 times, which is 68. and my decimal terminates. So the answer to this problem is 3 24 hundredths. All right, let's do one more, because I'm mean. No, I just want you to see another example. Okay, oh, this is a doozy. Nah, that's not so much a doozy. Okay, let's do this. Let's do an easy one. Why is it easy? Well, because I'm dividing by a one-digit number that's super easy to divide with. So I'm going to rewrite my problem. My dividend goes underneath the division symbol, and the divisor goes outside the front. So I check for, do I have a decimal point in my divisor? The answer is no, so I bring my decimal point straight up. I'm always looking back at my notes, right? How many times does 2 go into 5? It goes twice, which is 4, and I subtract, and I get a difference of 1. So then I go ahead and I bring down. How many times does 2 go into 16? Oh, that I remember that fact. It's 8 times. So I get 16, and I get no remainder. You're like, am I done? No. Nice try. Bring down the next digit. We can't finish until all the digits have been brought down. How many times does 2 go into 3? Only 1 time. So I subtract and I get 1, and then I've run out of digits. So I annex a 0, I bring it down, and I divide again. You guys getting the hang of this? So let's see, what do we get? 2 goes into 10 5 times evenly. So we finally terminate. So the answer to this problem is 2 815 thousandths. All right, we'll talk about this on Monday. Good luck, guys. Bye.